The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and thank you for joining our ANSYS Release 17 Update Seminar. Over the next 30 minutes or so, we will focus on some of the most popular and commonly used enhancements within the structural mechanics products of R17. My name is Brian Miller, and I'm pleased to be joined by my colleague Andrew Willenbrook. We will be holding a question and answer session at the end of today's presentation, so please post your questions using the panel within your GoToMeeting dialog box. For any of you who are not familiar with wired analysis, we have been involved as a channel partner with ANSYS for over 16 years. We provide a combination of software, training courses and consulting services through a very experienced technical support team who are also responsible for all first-tier support for our ANSYS clients. Within our support system, we offer a wide range of standard and customized training services, both at our offices and on site, to make sure you get the very most out of your ANSYS software investment. In addition to new capabilities within Release 17, ANSYS have launched a new product range for their structural mechanics solutions. This includes the addition of some productivity modules which were previously available as standalone modules at extra cost. We will go into more detail later about these modules, but for any of you who are interested in taking advantage of these new products, then there is the option to transition your existing licenses over to the new product range. Please contact us after the presentation for more information. I'd like you now to introduce Andrew, who uses ANSYS daily as part of our technical support, training and services team, to go into more detail about these capabilities.
Thank you very much, Brian. Before I start, I just mentioned that unfortunately we can't go through every single update to version 17 in the next 20 minutes, half an hour. There's just too many. So instead what I've got is just a summary of some of the more important updates that are going to affect everybody, and also some of the smaller changes, smaller usability changes that just make our lives a lot easier using the software. Okay, so the main change that Brian just touched on before is the change to the product packaging. So this is the introduction of 3 new license levels: Mechanical Pro, Mechanical Premium, and Mechanical Enterprise. These replace the older licensing system. The next update that we'll look at is 10 times faster. This is the buzzword that ANSYS is using around this new version 17 release. And this improvement in speed has really come from improvements in solver efficiency, usability enhancements, and closer integration with ANSYS SpaceClaim. We've also got improvements to the deformed geometry, improvements to general and non-linear adaptive meshing, increased crack modelling capabilities, and a new ACT extension for the prediction of composite cure behaviour. So starting off with 10 times faster. Now this is quite a bold claim, but based on comparing version 17 with maybe version 15, version 14, I think this 10 times faster really has been achieved in some areas. So the main reason that version 17 is faster than previous versions is the introduction of what's called distributed memory parallel. This really is just a change to how the software shares memory between each CPU core, and it results in a faster solution and also much better scalability than previous releases. Now this was available in previous releases, but it was quite limited. You could only use it with specific solvers, and you had to install additional software, and it had to take a bit of setting up. Whereas now in version 17 this is available in a lot wider range of solvers. It's all set up by default. There's nothing the user has to do. So if we just take an example, comparing version 16 to version 17, this is of a modal analysis of a gearbox housing. We can see a comparison of the modal analysis with 1, 2, 4, 8 and 16 cores, all based on a comparison between version 16 on one core, and then we're looking at the speed ups for the rest of the simulations. So we can see at 1 and 2 cores, version 17 is almost twice as fast as version 16. And we can see at 4, 8 and 16 cores as well. We can also see that version 16 doesn't scale particularly well, whereas version 17 now scales a lot better and is significantly faster than version 16. So this means our users with HPC licenses will now start to see much faster simulations when they're using those HPC licenses to run on multiple cores. This comparison is based on a modal analysis. If you'd like to see additional comparisons for structural analysis, please do get in touch and we can pass those on. So continuing, we'll look at closer integration with ANSYS Space Claim direct modeling. Now, for those of you that are not familiar with ANSYS Space Claim, this is a direct modeling geometry CAE prep tool. It's specifically designed for prep for analysis, and it's got a number of dedicated tools in there for things like creating mid-surfaces, extracting beams. Now, the difference between a direct modeling tool, which is what Space Claim is, and a feature-based modeling tool, which is the sort of traditional CAD packages, is with direct modeling we don't have a list of features. So extrudes, revolves, rounds and things like that we tend to get in a traditional CAD package. That may sound quite alien and it is a bit strange when you first start using Space Claim, but for preparing geometry for FEA it really does work and it is significantly quicker to use than a feature-based model. The other benefit of Space Claim is we can import a wide range of geometry files, whether they're specific to a CAD package like Inventor, SolidWorks, or generic files such as step files, IGES files, STL files, for example. We can import those straight into the Space Claim with no additional licenses required. Now we can work with those in exactly the same way as we work with a native Space Claim file. Space Claim is included free of charge for anybody that has a mechanical enterprise license. I'd highly recommend taking a look at this if you do have one of these licenses. One of the stories that I do like to say when I'm demoing this software to clients is at our office now we've got maybe 15-20 engineers. They use ANSYS full time, and 3-4 years ago all they used was ANSYS Direct Modeler, which is a feature-based package. This was all that was available then. Space Claim didn't exist back then. But over the course of 2-3 years since Space Claim was released, all engineers in the office now use Space Claim as their go-to package. I myself haven't used as a design modeler for maybe 2.5 years now. And that's not because Space Claim does anything new or exciting compared to design modeler. It just does everything a hell of a lot quicker and it's a hell of a lot easier to use. So if we start to look at some of the updates to Space Claim, the first one is we've now got an automatic tool for creating clip geometry and a name selection for the cut boundaries with when we're creating submodels in Workbench. So what we'd use this for, if we're using submodels in Workbench, we can automatically we can define a clipping volume in Space Claim. Space Claim will then automatically clip the geometry. It will also automatically create a name selection that will be imported into ANSYS Mechanical of all the cut boundaries that we can then use in Mechanical to define our imported loads from our global model. So this just really streamlines the process of creating submodels from larger geometry. We can now also import ECAD files directly into Space Claim. An ECAD file contains all the layer information, all the position of components, etc., for PCB boards. Now I can import this straight into Space Claim. No need to go through any intermediate packages to bring this in now. And what we can do is we can map that layer information straight onto either a 2D using shell elements or a 3D model of a PCB board and then import that straight into ANSYS Mechanical. So again, this just streamlines the whole process of creating a model of a PCB board. And it also allows us to include a lot more detail in our analysis simply because it's a lot easier to do now, so why not? For mechanical users, there is now a automatic weld bodies creation tool in Space Claim. I know myself, and I'm sure everybody else that's used Space Claim a lot to create fabricated structures has spent a lot of time creating weld bodies or just pulling surfaces just to connect them up, so when we import them into Mechanical, everything mesh connects nicely. For a lot of parts this is quite simple, but for some parts where you've not got straightforward joints, this can be quite a time-consuming process. Now in the new version of SpaceClaim there's a tool to do this automatically. It really is just as simple as clicking the edges on one part. On the example on screen, this would be the purple part, and then picking the faces on the other part on screen, this would be the blue part, hitting the enter button, and the body in orange is automatically created. And then when we import this into Workbench, the two parts will be mesh connected, so there's no need to define any additional contacts or anything in there. And this is all done, like I mentioned, with this automatic weld body creation tool. So moving on to usability enhancements. Cap section view. So this, in previous versions of Mechanical, the section view through solids was quite difficult to use. All you would see is sort of a hollowed out view of the solid bodies. And it was very difficult to see where one part started and another one ended, and it wasn't very useful. In version 17 this has been improved upon by simply adding a hatched cap to all of the solid bodies. So now, as you can see in the example on the screen, it makes this plot a lot more usable. We can see where one part starts and the other one finishes, and it just makes this plot a lot nicer and easier to use. Continuing on with the usability enhancements, we've got improvements to the colour by material plot. Again, in previous versions this wasn't particularly useful. The colours weren't very good. You get lots of different shades of grey and beige, which were quite difficult to tell apart. And when you hit one part, all the colours would update as well. So it wasn't very nice to use. Now in version 17 we can manually specify colours in the engineering data tab for each material. So if we want to set something to bright red, bright green or something so it stands out, we can do that, and then when we use the colour by materials plot in Workbench, it's obvious which parts are made from which material, and the colours won't change when we hide and show bodies as well. We've got increased grouping capabilities in version 17. So this was introduced in version 16, it's now been extended upon in version 17. This is now available throughout the whole tree. Previously this was quite limited in what areas of the tree you could use it on. We've also got the addition of a Find Objects in Tree tool. This really is as simple as a search box, same as how you search a Word document, for example. You can now search the tree for something that's got a given name, either a name that you've defined by yourself or a name that you've used, an automatic name, sorry, that's been generated by Mechanical. Now working with deformed geometry, this was something that was overly complicated in previous versions. You had to use things like command snippets and go into FE Modeler if you wanted to export the deformed geometry from the model. It wasn't very easy to use. Version 17, this has now been improved upon. So for example, if we wanted to do a post-buckler analysis where we're taking the deformed geometry from one analysis and using that as the starting geometry for another analysis, you can very easily drag and drop the solution icon in one system in Workbench and drop that onto the model icon in another system in Workbench. In the example shown on screen, that's connecting the linear buckling system B to the static structural system C. Then there's a couple of options we'll have to define. So this will be, in this case, which buckling mode we're taking across, and also a scaling factor as well. So now when we open the static structural, the geometry that we'll see is the deformed shape that's been pulled across from the linear buckling. This is a lot easier than it was before. It's a lot more streamlined and it's a lot quicker to use. In addition to that, we can now also export our deformed geometry directly as an STL file. To do this, we simply right-click on the total geometry plot, go to Export and then hit STL file, and it'll generate an STL file of the deformed geometry that's shown on screen. We can then take that deformed geometry into a package like SpaceClaim, for example. It's got some really good STL editing features, and we can maybe smooth that geometry out and use that for some additional analysis or use it for some marketing purposes. Now, general meshing enhancements. As you'd expect with each new release of the software, there have been improvements to the meshing algorithms, and that's the same in version 17. So the example shown on screen, got two parts meshed with the same settings, one in version 16, one in version 17. And you can see in version 16 around the radius, which is highlighted with the arrow, you can see that we've got part of it that's got 2 elements across the radius, then it drops down to 1 and then back up to 2 again. And firstly, this just doesn't look very nice, and also it will create a very peaky stresses around those changes from 1 to 2 elements, which we don't want. Version 17, this has been improved upon, as you can see on screen. So we've got much better what's called feature capture now in version 17. This is all by default. These are the default mesh settings. We've also got the addition of a non-linear mechanical shape checking tool in version 17. So the 2 parts shown on screen now, these are both meshed in version 17, but one with the standard shape checking and one with non-linear shape checking. You can see the quality is improved from 0.03 to almost 0.07. So sizable increase in element quality, and associated with that we do get a small increase in the number of nodes as you'd expect. Now this is really aimed at problems where we've got large deformation, so problems where we might have seen issues with elemental deformation will benefit from this new element shape checking tool. We also get the addition of a match mesh feature control for contact definitions in version 17. So what this does is it essentially matches the position of nodes on the contact and the target surfaces of a contact pair. So this just ensures we've got direct node-to-node contact across the contact, which just improves our contact conversions and it helps the solution progress. Now, non-linear adaptive meshing, this was introduced a few versions ago. Non-linear adaptive meshing is abbreviated to NLAD. Now this was, for those of you that are not familiar, this is a tool for updating the mesh of a component during the solution. So in the example on screen you can see just underneath the tip as this part is being sort of extruded out, you can see the mesh update as the part is squashed between the 2 bodies. This sort of application will be used for typically sealing applications when we're using hyperelastic material models. Version 17, the improvements we've made to this are the ability to now do 2D NLAD analysis, whereas previously this was limited to 3D. So the example on screen is a 2D plane strain analysis. We now also support self-contact between NLAD regions. So this is when a body deforms in such a way that it comes into contact with itself. We've also got improved mesh checking criteria. So this is the criteria that the software uses to determine when a remesh is required during the solution. Now, fraction modelling, I understand this is probably quite a niche subject, but there's been some important changes here that are worth mentioning. In previous versions we've been quite limited in what shape of crack we can model in mechanical. I believe it was limited to just a halfpenny shaped crack. Whereas in version 17 we can now model any arbitrary shaped crack, either planar or non-planar. We can then automatically insert this into the base mesh and run our mechanical analysis based on sort of any arbitrary shaped crack. So this is really an improvement because we've not got to make any assumptions about the shape of the crack like we would have had to do previously. So we're going to get more accurate results and better reflect reality. To go with those improvements in the fracture shape meshing, we've also got some additional post-processing results for crack meshes. So I've got 3 examples on screen. There are some additional ones. If you do check out the help files, there will be a full list of all the new post-processing plots available for fracture. The examples on screen are crack face pressure, T-stress and material force. These are all new in version 17. All of these also work with both regular and arbitrary shaped cracks. Now, composite cure. It can be quite common when composite parts undergo the curing process, so when they're sort of baked in an autoclave, residual stresses are introduced and the part can start to warp and deform. Now use a new ACT extension to help predict that behaviour. So we can predict how a part's going to shrink and deform during this curing process. We can also look at the residual stresses introduced as well. So if we've got issues with parts maybe not fitting together after they've been cured, or parts failing prematurely, this new ACT extension will help us predict that behaviour. Now that's it for the update section of the webinar. What I've also got is a few slides on some of the new packages that users upgrading to the new version 17 licensing system will get access to. So starting off with the fatigue module, this is available at the Mechanical Pro license level, so anybody upgrading to the new ANSYS version 17 licenses will get access to this. So this essentially just allows us to create contour plots of either life or damage ratio using an SM curve that we input into an engineering data tab. We can use either stress or strain-based methodology, and we can include the effects of mean stress correction in there as well. This requires minimal training. This tool is embedded in the mechanical user interface, so there's no need for additional training on how to use additional software, as long as the user's already familiar with fatigue analysis. The example shown on screen is a simple Conrad analysis. You can see this plot is of life, so the areas shown red and orange, these are the areas where we'd expect to see fatigue, we could expect to see fatigue failure during operation. Rigid body dynamics, this is included at the Mechanical Pro license level. So as the name suggests, rigid body dynamics is for doing simulations of dynamic analysis of rigid bodies, such as the example shown on screen. Typical applications would be things like aircraft landing gear, robotic manipulators, things like that. We might use this package to investigate things like joint loads, look at the motion and paths, for example. Rigid body dynamics also supports full nonlinear contact, so that's full frictionless and frictional contact is supported in there. It will also include the effects of a restitution factor as well in any contacts that we define. We can combine both rigid and flexible bodies in this analysis as well, so if we have one part in there that we want to consider flexible and look at the stress levels in that part, we can do that as long as we've got the right licensing levels. ANSYS Space Claim Direct Modeler, I mentioned this before so I won't go over it too much. This is included at the mechanical enterprise level, and if the users that do have access to this, I would highly recommend taking a look at it. It is a fantastic tool and it is very, very quick to use. Design Explorer, now, this is a very powerful tool. This is included at the mechanical enterprise level. And it builds upon the parameters tools that you'll have in your mechanical license. So with parameters, we typically define input-output parameters. Input parameters are typically things like CAD dimensions, so dimensions of parts, thicknesses, holes, for example. Output parameters are typically things like stress levels, deformation, component mass. Now what we can do with Design Explorer is we can ask the software to take a model and then go away and vary all input parameters up or down by say 10-20%. And then record all of the output parameters. The software will do this automatically, so it's the sort of thing you're going to set going and leave it overnight. You'll come back in the morning, it would have generated a huge data set based on all the input parameters, all the output parameters. It'll run a number of simulations, it'll decide which simulations to run automatically. It'll also decide how many to run automatically. Once it's decided that it's picked up suitable trends between input and output parameters, it'll stop running new simulations. And then there are some fantastic graphical plotting tools to start to investigate all of that data, so the user can then start to understand which input parameters relate to which output parameters, and therefore which ones are sort of candidates for optimization. optimised results. You can then choose to interrogate those further and maybe make a judgment call over which one to go proceed with. This is a very powerful tool for first understanding how your model behaves to changes in input parameters, and then also optimising your design as well. This is included at the mechanical enterprise level. So explicit dynamics. Now an explicit solver differs from a sort of traditional implicit solver that we'd use for structural analysis. By not enforcing equilibrium at the end of each load step, highly nonlinear, or maybe we've got very short severe shock loading, or very large deformations or material failure where we need to use a very small time step anyway. It's beneficial and much quicker to use an explicit solver rather than an implicit solver. So typical examples of this are the one shown on the screen, a can being crushed. This is involving very large deformations and highly nonlinear. Other examples are drop tests. So this is involving shock loading, and then impact and penetration. So penetration being material failure, again highly nonlinear behaviour. So these explicit tools are again integrated into the mechanical user interface. So users who are already familiar with mechanical and explicit analysis will require no additional training to use these new tools. Level. Yeah, the ANSYS customization suite, what they say, customized toolbars and toolkits. So if you were to create a customized button on your screen, for example, to execute some commands or something like that, you can do that with this ANSYS customization suite. We can also use it to, for example, encapsulate APDL command snippets, embed third-party applications or communicate with third-party applications, something like Excel or MATLAB maybe. We can also use it to create new post-processing tools, so if there's some additional results that we want to plot, we can use this customization suite now to create these ACT extensions to do this. Examples of these ACT extensions that have already been created, either by ANSYS or other parties, can be found on the ANSYS customer portal. These can be downloaded. Most are free, some are paid, and all users can download these regardless of what license level they've got, and they can install these and use these. A couple of examples are simple things like adding additional hotkeys. Another example is enabling element birth death. So this is just enabling, just facilitating the use of some APDL command snippets. And some more advanced examples is like the composite cure analysis, which I mentioned previously, which is an ACT extension. Like I said, all users can download an ACT extension and run an ACT extension. It's just users that have got the ANSYS customization suite that can write these ACT extensions. Okay, so just to summarise some of the points we've been over, the major updates to release 17 are 10 times faster. Again, comparing this to maybe version 14, version 15, this has definitely been achieved in a number of areas. Version 17, this is done by the addition of the distributed memory parallel solvers. Usability enhancements, closer integration with ANSYS space claim, improved general and nonlinear adaptive meshing. We're also getting increased crack modelling capabilities. In version 17 we can model any arbitrary shaped crack now. The addition of a new workflow for predicting composite cure behaviour. And we've also got extra extra modules included in our new ANSYS version 17 license, which we might not have had access to before. So I'll just pass you back over to my colleague Brian Miller now, who will just finish off today.
Okay, Andrew, thanks very much. By the way, I've just heard that we may have had a few dropouts on our audio during this presentation, so apologies if this occurred to you, and obviously anything we've missed, please contact us and we'll obviously provide you with the right information. Just before we move on to a question and answer session, I would just like to make you aware of two more webinars which we're holding tomorrow. The first focusing on the updates to the CFD solutions within ANSYS, that's both the Fluent and CFX solvers. We're running this tomorrow at 11 o'clock in the morning, and that will be followed in the afternoon by the ANSYS AIM Release 17 update seminar. Now, for any of you who are not aware, AIM is a relatively new product from ANSYS. It's an integrated FEA and CFD and indeed electromagnetics multi-physics solution targeted for design engineers. So when for quickly running both single and multi-physics simulations, it's very much a wizard-driven structured workflow interface built upon ANSYS Workbench. This is gaining a lot of interest, and I would certainly recommend you take a look at it if you can, just to see if it does sort of fit in with some of the activities that you run at your organisation. Both of these events you can register for them at our at our website as shown here. Alternatively, just drop us an email and we'll make sure that we save a place for you. If you're interested in finding out more about some of the capabilities today, then obviously you're more than welcome to join one of our training courses. We're running some in the very near future. Firstly, the standard mechanical introduction course, which may be of interest to any of your colleagues who are perhaps less familiar with ANSYS than yourselves. This will go through most of the basics of running a structural mechanics problem within ANSYS. We're also running a course specifically on ANSYS space claim. Now, for many, space claim is so intuitive that maybe training isn't required, but if you would like to understand all the features of space claim and to ensure that you understand how it would work well for your organisation, then we're running a special one-day course in early June. We're also running a course in May on explicit dynamics for sort of impact type problems, as Andrew talked about earlier, for the explicit STR module. And in the very near future, we're running a one-day course on Design Explorer for design of experiments, robust design and general optimization studies using ANSYS. And again, as with our events, you can get full details of our training courses at our website, but please do not hesitate to contact us if you require any further information. So, I think it's now a good time to move on to any questions. I'll just see if we can see those questions. I've got a few here to start with. Let's see how much time we've got to cover all the questions posted today. Firstly, is there any difference in the hardware requirements of version 17, Andrew, compared with the last release for running ANSYS?
No, not really. There's no real change in hardware requirements. What you might notice though is if you do run the same model in version 16 and version 17, the introduction of the new distributed memory parallel will use a little bit more memory compared to version 16, but that's the only real significant change you're going to see. There's no changes in sort of the minimum hardware required to run the software.
Okay. Another question here. You looked at the deformed shape capability. Does that actually carry over the stresses when starting a new simulation?
No, that doesn't carry over the stresses. It just carries over the deformed shape. But you can carry over stresses if you want to, using some. You have to use some additional APDL command snippets. So it definitely is doable inside Workbench if you do want to do it.
Okay. With Design Explorer, we have a client here who would like to deal with things such as plate thicknesses, which I guess it's not a continuous value, it only comes in discrete thicknesses. Is that something that can be done with Design Explorer?
Yeah, that's definitely something we can do in Design Explorer. What we have a tool is called manufacturable values. So like the example that Brian mentioned, plate thickness, hole size for example. Obviously you can't make a plate, well, you don't really want to be making a plate thickness that's 2.98 millimeters thick. So what you can do is you can specify a list of manufacturable values. So for plate thickness, that might be 1, 2, 3, 4, 5 millimeters, let's say. And then that will tell the design modeler only to run simulations with those plate thicknesses, those discrete values. It won't use any sort of intermediate values.
Okay. Okay. Well, I think we've got one final question here regarding some of the modules looked at the end. Are those modules now only available within the ANSYS products, or can I still get them separately? Perhaps that's a good one for me to answer. It really depends on what modules. The solver modules are now basically integrated with the appropriate product level. The things such as Design Explorer and Space Claim, if you have a lower level version of ANSYS, which doesn't include these by default, then you can still purchase them separately. And certainly with both Space Claim and Design Explorer, I would encourage you to look at those, because we found that they can be very useful regardless of the complexity of your simulation. Okay, I think that's all we have time for this afternoon. Many thanks for your attention, and as mentioned before, if anything you've seen today is of interest, then please contact us for further information, and hopefully we'll hear from you soon. Thank you very much.